Best practices for large-scale workload migration projects. As a first best practice, Platespin recommends to always test a workload at least once in its new target environment before cutting it over in production. Testing the target workload before cutover is very easy with Platespin and is typically done in a sandboxed environment while the source workload is still online in production. Isolating the target workload in a network sandbox ensures that when it boots, it won't disrupt services running on the source workload. You can also configure the target workload to come up with a different IP address while testing. There is no limit on how often or how long you test, so you can test as long as needed to get sign-off from the business teams. Once complete sign-off is received, the workload can be cut over. Cutover is the moment in the migration process where the source workload is brought down and where the target workload is booted into its final production environment. The cutover is preceded by a final incremental replication. This incremental replication synchronizes all changes that have happened on the source workload during the initial full replication and while the tests were happening. Platespin advises to shut down the business services on the source workload before the final incremental replication and cutover. This guarantees that 100% of the application data is copied over from the source workload to the target workload. Platespin Migrate allows administrators to configure the shutdown of services on the source workload during this phase of the migration process, so that no manual intervention is needed at the moment of the cutover itself. If testing the workload has taken a lot of time, lots of changes will have accumulated between the moment of the initial full replication and the moment of the final incremental replication. The more changes need to be synchronized, the longer the final incremental replication will take, and the longer the service downtime will be. To avoid a long service downtime, Platespin recommends to perform regular incremental replications prior to the final incremental replication. If the Platespin web UI is used, then these incremental replications can be scheduled to happen automatically overnight. This slide shows how testing can be interleaved with regular incremental replications. The top row shows the migration process from discovery to migration configuration to initial full replication to a first test that has failed. Because the failed test means that more testing is going to be needed, an incremental replication is performed. The second test also fails and is followed by another incremental replication. The third test proves to be successful and is then followed by the final incremental replication and cutover. Because of the regular incremental replications, only the data that changed since the previous incremental replication has to be synchronized. This keeps the service downtime very short. Note that performing regular incremental replications also has another advantage. If performed at roughly the same interval, it will allow to predict how long the final incremental replication will take. This will give an idea about the expected service downtime when cutting over. For Windows source workloads, the time needed for the final incremental replication can be reduced even further by using the block-based transfer or BBT driver for the migration process. Remember that installing this driver requires the source workload to be rebooted. Linux workloads do not require a reboot, so the BBT driver is always automatically used for Linux workloads. Because of the reboot requirement for Windows workloads, it's important that each time you begin a project, you make a plan to get the BBT drivers installed. A standalone installer for the driver is available and may be used to install the driver during maintenance windows. Sometimes installing a new driver on workloads will require driver certification, especially in large enterprises and financial institutions. To avoid unnecessary delays in the project, start the certification process as soon as possible. Another aspect that might require some upfront investigation is the amount of free disk space on each source workload. Platespin Migrate has the following requirements for free disk space on source workloads. 1. It requires 100 megabytes of free disk space on the system volume for the installation of the Platespin Migrate controller. The installation of the controller happens automatically, but is necessary for the migration to succeed. 2. For Windows workloads, Platespin Migrate uses the Volume Shadow Copy Service, or VSS, to guarantee application-level consistency in the replication data. A VSS snapshot is taken prior to each replication and is maintained as long as the replication is running. Depending on the activity for the volume, the snapshot may grow in size during the replication. To accommodate for this growing snapshot, Platespin recommends to make sure that each volume has at least 10% of free space available. 3. For Linux workloads, a similar requirement exists, but only if LVM is used, and in that case, the 10% of free space is required at the volume group level, not at the level of the individual volumes. On the topic of volumes, it's important to note that sometimes source workloads that haven't been rebooted for a long time may have accumulated file system corruptions. When block-based replication is used, these corruptions are copied over from the source to the target, and they may prevent the target from booting up correctly, just like the source workload wouldn't correctly boot if it was to be rebooted. To avoid this scenario, Platespin recommends to test the integrity of the source workload's file systems before starting their replications, especially if they haven't been rebooted for very long periods of time. For Windows workloads, the check disk utility can be used. For Linux workloads, similar utilities are available depending on the file system that's being used. Now let's talk about scalability limits, and we'll talk about the Platespin Migrate server first. One Platespin Migrate server can handle approximately 200 workload migrations at the same time. These migrations can be in any state, from initial discovery to cutover. Deleting cutover workloads makes room for more workloads to be discovered. As such, this limit of 200 workloads is a sliding window. Of the 200 workloads that can be managed by one Platespin Migrate server, 40 can be replicating data at the same time. This means that 40 workloads can perform their initial full replication or an incremental replication at the same time. On the target side, each Platespin Migrate server can handle 30 individually configured targets. Note that for VMware clusters, it is the individual hosts that become the targets. So for example, one Platespin Migrate server can handle 15 clusters or 2 hosts each, or 10 clusters of 30 hosts each. Note that there is no licensing impact if for any of the above reasons you need to install and configure multiple Platespin Migrate servers. Purchased licenses can easily be spread across multiple Platespin Migrate servers, and there is no limit on the amount of Platespin Migrate servers that you install for your project. Replicating workloads into a virtualized target platform generates network and storage-related stress on that target platform. If the platform features shared resources, as is the case for all hypervisors, then this stress may negatively impact other workloads that are running on the target platform while migrations are happening. If this needs to be avoided, either run the migrations at night or adopt a two-stage approach where workloads are migrated into a staged target platform, where no production workloads are running, and are then moved to their final production destination. An additional consideration is the speed at which the target platform can handle incoming replications. Based on experience, Platespin recommends not to perform more than 10 concurrent replications into one VMware cluster. On the source platform, CPU, RAM, and storage-related stress is less of an issue as the data is only being read, not written. However, replicating workloads can still generate significant network-related stress on the source platform. An important related factor to take into consideration here is the network bandwidth of the network card, NIC, virtual or physical, that links the source platform to its back-end network infrastructure. No matter the speed of that network infrastructure, any migration will not be able to consume more bandwidth than offered by the connecting NIC. This is even more important in virtualized environments where one physical NIC can be shared by multiple workloads. If that NIC is 1 gigabit per second, and if multiple workloads are being replicated at the same time, then all replications will have to share the 1 gigabit per second link, which will lead to very poor migration speeds, even on a 10 gigabit per second or better network infrastructure. Even when fast theoretical, e.g. 10 gigabits per second, network speeds are available, Calculations need to be made to ensure that the available bandwidth is sufficient for the amount of data that needs to be moved simultaneously. As early as possible in the project, the real available bandwidth, i.e. throughput, should be determined between the source workload and the target platform, as this throughput will have a significant impact on the real migration speeds. A good way to measure throughput is using the IPerf tool. IPerf is a client-server-based tool, where the server component should be run on the target platform. For a VMware-based target, this can be done in a small, dedicated virtual machine. The client part can then be downloaded and launched on the source workload, after which the throughput between source workload and target platform can be measured. Platespin highly recommends to measure all available throughput for all source workloads to target platform network paths before the start of the actual migrations. Note that starting with version 12.2, Platespin Migrate has the IPerf tool on board for this purpose. Consult the Platespin Migrate documentation to learn how to use the IPerf tool. On high latency networks, the TCP/IP receive window between the source workload and the target workload can be tuned to achieve greater throughput during replications. Furthermore, every networking infrastructure has a characteristic size of messages that may be transmitted, called the Maximum Transmission Unit, MTU. Platespin Migrate allows administrators to set the MTU for any given replication to avoid packet fragmentation and related loss of throughput performance. Consult the Platespin Migrate documentation for more information on these topics. For very slow links, such as WAN links, Platespin Migrate allows compression to be used to compress the data before it's being sent over the network. Depending on the type of data, compression of up to 70% can be obtained, leading to much faster replication times. However, since the CPU on the source workload is used to compress the data, an additional CPU overhead of about 5% has to be taken into account. In the next couple of slides, we're going to talk about required network communication paths. This is a very important topic, especially as it relates to networking. Block network communication paths are the #1 reason why migrations fail. The good news is that with proper knowledge of the product and the environment, all of these problems can be eliminated well before the actual migrations start. In order to understand the required network communication paths, we need to talk about the Platespin Migrate Take Control mode. Essentially, whenever Platespin Migrate is replicating a workload, the target workload is booted from a Linux RAM disk, LRD, helper ISO. For migrations to virtual platforms or the cloud, this ISO is distributed automatically via Platespin Migrate, so there is no management requirement for the user. Whenever the target workload is booted from the LRD ISO, we say it's in Take Control mode. The only times where a target workload will boot from its own disks are the times where you bring it up for testing, and of course also when you have cut it over into production. Now that you understand Take Control mode, you will also understand that there are always 4 different IP addresses in play during a migration process. The IP address of the source workload, this is fixed. The IP address of the Platespin Migrate server, this is fixed. The IP address of the target workload in its final configuration. This IP address will usually be the same as the source workloads, but it can be different if you configure it that way. And the IP address of the LRD ISO helper image during replications while the target workload is in Take Control mode. This last IP address deserves some more attention. Essentially, there are 2 scenarios. If the IP address of the source workload will be transferred to the target workload in its final configuration, then a dedicated IP address needs to be planned for the LRD ISO during replications. If the IP address of the target workload in its final configuration is going to be different than the IP address of the source workload, then you can use the same IP address for the LRD ISO during replications and for the target workload in its final configuration. Note that if DHCP is used in the environment where the target workload will reside, IP address assignment will mostly be handled automatically by the DHCP service for both the LRD ISO during replications and the target workload in its final configuration. Now that we have a good grip on IP address requirements, let's talk about network connectivity requirements. In a nutshell, we need connectivity between Platespin Migrate server and the source workload, connectivity between the Platespin Migrate server and the Linux RAM disk, LRD, helper ISO image during replications. This connectivity can be a dedicated network, if desired, which can be selected during the migration configuration. Connectivity between the source workload and that same LRD helper ISO image during replications. This connection will be used for the replication traffic, so it needs the most scrutiny regarding throughput. Connectivity between the Platespin Migrate server and the target platform to which the workload is being migrated. Connectivity between the Platespin Migrate server and the target workload when it's booted from its own disks during testing and also after the final cutover or final configuration. This diagram lists the connectivity requirements in greater detail and with the required ports listed. The main port requirement for a successful migration is the requirement that the target workload, in take control mode, can make a network connection to the source workload on port 3725. Note that this port is configurable and that the direction of the connection can be reversed so that the source workload reaches out to the target workload. For more details on port requirements, consult the Platespin Migrate documentation. For your project team, Platespin recommends the following skills. All team members who operate Platespin Migrate should attend the Platespin Migrate administration training. This training is available in classroom format or in an online version. Visit the Micro Focus website for more details. In addition, at least one project team member should be a certified Platespin migration specialist. If Linux workloads need to be migrated, then Platespin recommends that at least one team member has good Linux administration skills. For certain versions of Linux, a custom BBT driver may need to be compiled. This process is not difficult and is well documented, but requires Linux command line interface administration skills. Check the product documentation for an overview of Linux versions for which a pre-compiled BBT driver already exists. Platespin highly recommends a good understanding of the target platforms to which workloads need to be migrated. Each target platform will have its own intricacies, and especially during problem resolution, at least intermediate knowledge about the target platform is required. For migrations to VMware target platforms, it's highly advised to have at least one team member be VMware certified. For migrations to other target platforms, it's advised to investigate if any certification for the platform exists, and to have at least one team member obtain this certification. Network-related issues are the #1 cause of migration challenges, whether they have to do with bandwidth constraints, firewalls, or network architectures which prevent required network communication paths. A good understanding of the networks involved in the project is critical for project success. Platespin strongly recommends to have at least one team member be certified in standard TCP/IP networking. Even with the right skill set in your project team, a migration project can go wrong because of poor planning. Platespin Migrate is a multi-user migration tool where multiple users will work on migrating workloads at the same time. To avoid human error, most often in the form of losing track who's working on what workload, or in the form of one administrator accidentally performing an operation on another administrator's workload, Platespin recommends to not have more than 3 administrators share the same Platespin Migrate server. One person can work on multiple Platespin Migrate servers, but one server should not be manned by more than 3 different people. Each team should be given a set of applications to migrate and should use one and the same Platespin Migrate server to migrate all workloads belonging to these applications. When Platespin Transformation Manager is used in addition to Platespin Migrate, these kinds of human errors are dramatically reduced, as you can divide your project into smaller waves and batches, and then assign users and roles to these waves and batches during the project planning phase.